Hello. So tonight we are looking at the first day of Advent of Code. This is the first time I'm doing Advent of Code, and um, because of lack of better preparation, I guess I'm doing it in Python because it's the language I know the most, and yeah, it will be fun. So the first puzzle, well, actually, Advent of Code works. It's advent calendar, and every day at midnight, somewhere, I guess in the US, they post new puzzle, and this is about like 6 a.m. for us in Europe. And if you manage to get through the puzzle, that normally it's hard enough, that requires you to write some code, you can put your answer, and then if your answer is correct, you can move on to the next puzzle. Hello. Um, so technically, I guess you can put the answer. There is a leaderboard and things like that. Totally not gonna do that. And also, I guess it's obvious to say that I am kind of preparing those things. I'm not writing code, but for sure, I'm looking at how to solve the problem somehow. A little, so it's almost improvised. I'm pretty sure I will do stupid mistakes on the code. So let's start with day one, and I'm not gonna read through the entire thing, even though it's pretty fun. I invite you to do it. But basically, we are decided that after saving Christmas for 5 years, we're going to a tropical island. This island has just a very strange currency that is a gold coin with a starfish logo. And we need to get our 50 star by December 25th. So we collect those stars solving the puzzles. And the puzzles are available each day, and after we complete the first puzzle, we get to a second one that obviously I can check in advance. So that's where the actual fun begins. So before leaving, the elves, apparently, in accounting, so maybe the worst of the worst, are asking us about expenses reports. So the worst of the worst of the worst. And in particular, they're going to give us a very long expense report, and we need to find the two entries that sum up to 2020, and then multiply those two numbers and give that as a result. So this is the first part of the exercise. Hello from chat. And in order to solve it, we are starting to first collect some, let's say, inputs and requirements, and then we will try to find possible approaches. So the problem is quite simple. Given a list of numbers, find the two that sum to 2020. Then multiply those two numbers together. And that's our output. So our input is a list of integers, and we have an example here. We have the long list there. I guess we can also say that those integers are usually either 3 or 4 digits, and they're not more than 4 digits. We don't really care, but The output is an integer that we have to see how to calculate. Well, it's actually the two sum blah blah blah. Well, okay, let's say the multiplication of the two integers that sum to 2020. Now, some interesting notes, and this is where it will get tricky, in the sense that depending on the type of things that we manage to notice from the problem, we can find ways to make the solution of the problem simpler. So the first thing that really pops my mind is that given the text, we are sure that there are only two numbers that sum up to 2020. And this is an incredibly important assumption for the solution we're going to write, because it will change a lot the way we will implement the code if we will have possibly multiple entries. And I'm pretty sure that this is something that maybe would get asked in the second part. Okay, and then another thing to note is that the list is not sorted, okay, easily. Like this is smaller than this, so, and yeah, many other. So the input is not sorted. Normally, info, like checking if the input is sorted, is something that makes a lot of sense when you try to write an algorithm, because it's a very strong assumption. Sorting is, let's say, generally expensive, and it will change a lot the way you can do stuff. In this particular case, it will change very much. And yeah, the fact that you might have only one single solution, hello, and or multiple solutions also can change the way you count. More simply, we are going to stop after we find the first sum. So if there are multiple than one in our list, we will ignore them. Okay. So one possible approach that we're going to call naive is to actually check every possible combination. So check every possible combination of two numbers in the input. Well, usually everything that contains every possible means that it will cost a lot. And this is exactly the case. I think that, I mean, we can afford to do that kind of computation with our list, because it's not that long, but of course that's not something you want to do. But I guess it makes sense to kind of benchmark this thing. And yeah, I'm very much sure we're not going to do it in time, but yeah, I mean, hopefully we can fit in 2 hours. So to check every possible combination, the cost of this thing, given that our input is long n, is okay, maybe I should not get into this kind of things. I mean, yeah, every possible combination. It's something around n exponential. It should be n times 2, because you're getting. So we will, the way you do that. So this is cost. So our upper cost. Why I'm able to say this? Well, I should explain how you would solve it this way first, maybe. But the way you do is like you pick the first number in the list, okay? And so you pick the first number of the list and you iterate on every other number if you spot the sum, you stop, okay? If not, else. Should I indent this thing? Iterate if else. Wait, I'm trying to find a nice way to pseudocode. Okay, let's do it like this. It's horrible. Else you pick the second number of the list and restart. Okay, so what does it mean? That given the worst case scenario that we need to have that the two numbers, let me write this. So the worst case scenario is that the two numbers are placed in position n and n minus 1, okay? So at the end of our list. And that means that we need to check every other possible combination and trash that result, okay? So should I write this code? And this is a question for the chat. They am like, whoa, asking things to people. And yeah, I will write this anyway, so fuck the chat. Okay, so let's write this thing. Why my shell is this big? We go dev, we create a folder AOC. I will put all those things in Git, on GitHub, like last time. We create a folder day 1. Yeah. And we need to get the numbers. Oh, thank you very much. What is your problem? Really? I don't really care. So, input txt. Okay, we have 200 numbers. And so vim our naive, okay, let's call it 01 naive solution by, and now day 1 naive solution. So, well, the first thing is our dummy input. Well, let's say input list, and we put those numbers there. Please, why I can't copy this? Okay. So this is our very nice. Okay, that's horrible. Huh. Come on, work with me. Huh. hate this. Better. Okay, whatever. So this is our input list. The thing we're going to do is to solution, get the programmer online. Yeah, but I mean, this is very simple. So bear with me. You're being able to solve this kind of thing. So find two numbers, and we're passing input list. We're passing the sum, and that's it. So the sum we want to look for is 2020, and we want to store our solution in a variable, and then we're gonna print our solution. So that's good for start. Now we create our function, find two numbers, input list sum, and yeah. So we need to pick the first number of the list, iterate every other number. Technically, we have to iterate twice. So 4 and 1 in maybe I want another space here. 4 and 1 in input list. 4 and 2 in input list. If n1 plus n2 is equal to sum, return n1 times n2. And I guess that's it. So we are picking the first number. We are iterating over any other number. If we spot the sum, meaning we return the multiplication. Otherwise, this is just doing nothing and it moves on. So fair enough. And this function, in case there is nothing giving us, I would have done it C style, enumerating cycles. What do you mean? I'm not so sure I understand what do you mean with enumerating cycles. But okay. Okay, so let's try this thing. Oh, nice. Python 2.7. 0 next solution. Ta-da! 5.4579. Here we go. So this works. Okay. So I'm seeing in the chat, somebody's saying, and it makes some sense. Instead of doing this, you could have used the for loop notation that is similar to C. So something like for e. Well, the thing that in C is int e I minus something like len input list E++. And with this, we could have done the internal cycle just using the same notation. I mean, that works. Sorry, because you won't be able to read this. So this is in J. Blah, blah, blah. And then you could have just done like if input list E plus input whatever J equal, and everything is the same. So notation wise, yes, you can, if you like to have okay, so I was saying notation wise they are the same. The thing is, you can't skip one cycle with this. You still have to put 2 cycles because you can't make assumption on how the list is done. So you still have to take the first one with the outer loop and then loop with the internal cycle. There are some borderline cases that we will need to manage in theory, that in particular if yeah, we are actually summing the number with each other. Haha, there are strange noises. Yeah, those are aliens. Amazing. Okay, so wait a second. Is it better now? Yeah, I do see that the mic is actually moving, even if I'm not speaking. Oh, it's moving a lot actually. Maybe like this. Okay, hopefully like this is a little better. And then the best solution to solve the noise issue is usually to tell your other person, shut the fuck up, please. I'm live. Yep. I'm sorry for the noise. I mean, one day I will get a real microphone. Right now I have a conference room microphone, so it's actually built to get as much shit as possible. Anyway, I was saying about different notation. Different notation can be cool, but I don't know, whatever, don't worry. But but they're not gonna solve our main problem. This thing is expensive. So what do I mean with expensive? I mean it takes time. Okay, so to see that, I will put some, oh yeah, like I remember this, Python get timestamp in nanoseconds, femtoseconds. I honestly don't know what is the precision you can get. Time ns. Yay! Okay. This is time ns, and hopefully I have Python 3.7. And this is finish time ns. So we're going to print the solution, and then we're going to print computed in finish time minus init time nanoseconds. So there are a lot of questions here. Can I actually do this kind of computation inside the string? And do I have Python 3.7? And have I cleaned the shit I just wrote? So am I imported? Yeah, okay. This was computed in some nanoseconds, okay? It's, for now, we don't care. We need to do another thing, that is to read the file. This is, yeah, like I remember. Yeah, okay, I don't care of remembering syntax. Python read list of lines from file. Stack Overflow is the best thing ever. Perfect. With open, I need my file that I called input.txt. As numbers. This is a terrible way, actually. What? Yeah, okay. Input file equal numbers, red lines. And then we're passing our input file. Will it work? Who knows? I fear that something, yeah, it didn't. Okay, now my volume is very low. Okay, sorry for this. Blah, blah, blah. Okay, yeah, to improve, there is a very, very simple trick, and we will see that later if I remember how to code Python, and apparently I don't. I mean, things happen. I don't care. Input file. Maybe I need to do this. It was a long time. I thought I didn't need to do this. And let's print it. Input file. Now everything is getting messy because I mostly don't know what I'm doing. Okay. So I needed to read the entire thing. How can it be? Yeah, whatever. Okay. So read split lines. I mean, I just want my numbers. I'm not getting them. I'm annoyed. Okay, so I do have my list of things. Oh, okay, yeah. And I need to convert those things into numbers. How do you do a cast? I guess it's like you put int. Okay, let's see all of this. Int. So, ooh, yeah, that can't work very well. So we need to write something less clever because I'm not able to write the clever part of this, and so it would be for num in numbers read lines. What they're telling me to do. Please tell me. In numbers input fine append integer num. And then we do input find equal empty thing. Is there a better way of doing this? Most probably. Do I really care about reading files right now? Totally not. Do I care about reading files in general? No, not really. Should you care about reading files properly? Absolutely yes. So, now we are ready to check what we did in a non-rushed way. We are running our code. This is our solution. And we computed this solution in a very long time, actually. A lot of nanoseconds. And so let's write it down. Solution la computed in whatever. Okay. Well, this was fun, but are we really happy that to read 200 numbers a bunch of times we need, I don't know how many nanoseconds are in 1 second, but this sounds like a lot of nanoseconds. This can be like 0.4 seconds. Yeah, something like that. Ish. And well, that's obviously terrible. You can trust me on the fact that this is terrible. So this is a better solution PI. And let's first check what can we do better, okay? So in the chat, somebody suggested, can we improve complexity using a binary search? Yes, kind of. The basic idea of how you would solve this in a little more efficient way is that we need to find ways to avoid this double iteration, okay? Because we are doing this double iteration doesn't give us anything really valuable. It's really just wasting time, especially because we just need to find 2 numbers, okay? And the fact that we're looking into numbers and that numbers have, in particular integers, they have a lot of very nice properties. First one being you can order them, and that the thing we are looking into those numbers is really another mathematical property. We can actually use these notions to find something a little smarter. So the idea is that if you order all those numbers, at some point, part of your list, it's actually bigger than the sum. And for sure, the 2 numbers you're looking for needs to be smaller than the total sum. At worst, if you have 0 in your list, one of them needs to be equal to 2020. This is not true if you start to have negative numbers. But do we have negative numbers? No. So that's another thing that we can note. And therefore, given the fact that they're not negative numbers, we can start building something better. So the first thing is we sort. Okay. The cost of sorting in this case, I mean, I'm not going to write the sorting algorithm. I will just use, I guess, the quick sort or whatever magical sorting pattern is giving me. But usually we can expect sorting these kind of things of being something on times n log n. Okay, so this is a little more than n, but not that much. And well, we're not finished. So after we sort, now we can start leveraging on the property that we just found. So we want to find those two numbers, and because our list is ordered, we can actually take the first and the last one. And we'll call them N1 and no, and first and first, last, it's better. And then we check. No, sorry, this is a terrible notation. So let's call them N first, and F, and NL. NF, Q, and L equal sum. And in that case, we are just doing the same as before. If yes, return. If it's not the sum, now we can do the smart thing. So if not, we check if an F plus an L is more than the sum. So if the two numbers we found summed together are bigger, it means that we need to replace one of them with something smaller. And then how can we find something smaller? Well, our list is sorted. So for sure, the number before an L, that as a reminder, it was the last one, it's smaller than this one. So if it's smaller, we take the number before an L and we repeat. Otherwise, it means that our sum is bigger. Sorry, yeah, our sum is bigger than the sum we're looking for. No, sorry, our sum is smaller than the sum we're looking for. And that means that we need to put a bigger number, okay? If it's, and again, where do we find a bigger number? Well, an L is supposed to be the last one. So, and we need to take the one after an F. And we repeat. Now, how long will it take to do this? For sure, we risk, for example, that we will need to do, okay, so let's try with some possible scenarios. let's imagine that we have the entire list that is composed of 1, okay? So we have all 1, and so then we have some numbers, we don't care. The last number is, in our case, 2018, okay? So we do 2018 plus 1, 2019. Okay, we need something bigger. But we move on, and it's still 1, it's still 1, blah, blah, blah. And the last one, the last number is magically 2. So we will need to have this iteration to get all the numbers once. But I mean, expensive, but the cost here is still n, because we are doing the iteration only once. And the opposite is also true. So imagine that the first number is actually Does this make sense? Yeah, so we have the first number being 9999, right? Yeah, no, we are order. Ha. So yeah, let's have the last one being too big. Yeah, okay. Then everything is 1, and then we have we can even have yeah, 2019 here, it doesn't really matter. So what's going to happen here? We are taking 1, and then we sum it with 9999. So the result is a number that's bigger than sum, and so we move to sorry, I was saying bullshit. Okay, so we have 9999. We sum it with 1. It's still big. So because it's bigger than the sum, we are decreasing our from the last one. So we're going back, and magically our number is the second one. This is another worst case scenario, but still it takes just one iteration to get through this. There is another situation that's actually annoying to write, that's composed like this. Now, yeah, I'm saying there are repetitions. Yeah, there are repetitions, and then 9999. So here the situation is that you have in the middle of your array, of your list, exactly in the middle, you have it doesn't really matter, but you have exactly the 2 numbers that will make your sum. In this case, I put exactly the half, just to, I don't know, be messy. So that means that you will start from the first number, you go to the last one, and then you start to move on. So depending if this sum is bigger or lower, you will start moving from one side, and then you will start moving from another side. Anyway, the total movement in this case is from the first half side plus the movement from the other half side. So anyway, the total is still n. So, well, this might not be the perfectly fine proof of what I'm going to say, but we can confidently say that this for loop will cost n at best. Yes, this part, yeah, exactly. It's very similar to some sort algorithms. So the total cost is something around big O and log n plus n, and that stands in the order, because those are order of magnitudes, is still n log n. So we're doing this computation actually at the same worst case scenario cost than just sorting. And this is pretty good. It means that our computation, it's kind of free, given that we have to sort it. So let's see if I'm right. We get our better solution. We are inputting our files. Now, I will count the time to sort because I'm a nice person. And I'm not sure what's the notation, but it should be like something like sort. Is it magical like this? This is just to test notation. You totally not the right way. Was it sort like this? Yeah, maybe it makes actually more sense. Okay. Well, forget about this right now. We don't. This is not correct. So our input now is sorted. Wait. We can do it better. We just sort inside our function. This is just smarter. So our input list, okay, we are sorting it, and then we have to do our magical iteration. So in this case, to do the iteration, it's it's easier if we just we will have to handle the loop kind of ourselves. So we put our first thing as 0 and the last as len of input list, and maybe I need a -1. Maybe I need a -1, I guess. Yeah, usually you need a -1. Let's say I need a -1. And then we will use a while. And in our while, we have to check if we are hitting the border. So yeah, that's something I didn't write down, but ideally, well, at some point, okay, sorry. If you want to just do the while loop on your list, you just start from the small item up to the highest one, and so you want to continue your loop up until until the last one. This is NL, and this is NF. That makes sense. NL and F. So you want to loop up until your small number, let's say, it stays smaller than the big one. It's just an iterator. So Imagine you start, this is 0, and then the next time this is 1, 2, 3, 4, etc. Or if this stays 0 and you're decreasing 1, this is like, well, in our case, it would be 200, 199, etc. Of course, it doesn't make sense to have those two things hitting together or having one jumping the other, because that will mean you already checked those numbers, and so there is you have no interest in checking them again. Actually, if you're checking them again, you're back on our old solution. Sorry, that is still this one. Okay, and I'm going to trash it. So when you are inside your while, we do this. We check if the two numbers we picked are equal to the sum. So input list and f plus input list and L. Okay, wait a moment. There is no parenthesis in the if. Equal sum. If so, what's happening here? We return input list f times input list and L. Okay. If this is not going to happen, we check if input list and f is bigger than the sum. If it's bigger than the sum, it means that we have to reduce from the last. So NL is equal to NL minus 1. Else, it means that we need to increase. So NF is equal to NF plus 1. And that should be it. We don't care about our dummy input either. Woo! Okay. So this is our computation. So there are two interesting things here to see. Well, the first one is that the solution is the same. And that, I mean, given that we wrote two different algorithms to write this, the solution stays the same. Actually, the solution stayed the same even if we sorted on the previous algorithm, so even better. That means, I mean, we can be pretty confident that the solution is right. And of course, we were confident that the solution was right because we wrote our pseudocode and we kind of proof it. Yeah. The nice thing is the time. Just to demonstrate this is not a real fluke, the worst I can see here is 116,000, but most of the time this is around 76,000. Okay, trust me, this is very scientific, and this is way better than 455,000. I mean, it's like 400,000 less, kinda. So it's, yeah, it's like an order of magnitude less. Like we're losing a full digit on this solution, and that's it. Yeah, I was right. I'm happy now. Okay. I knew that. So let's save this. Let's CP. Well, no, let's wait. Now, we moved on. This is amazing. Okay, not too much. Now I will mess with Windows because why not? And now we can read the second part of the problem. And this part is completely new, so totally unprepared for this. So the elves in accounting are thankful for your help. One of them even offered you a starfish coin they had left over from a past vacation. Nice. They offer you a second one if you can find 3 numbers in your expense report that meet the same criteria. Using the above example again, the 3 entries that sum to 2020 are 979, 366, blah, blah, blah. Okay, here. Multiplying them together produce the answer, whatever. If your expense report, in your expense report, what is the product of the 3 entries that sum to 2020? Okay. So this is interesting. And well, the input is the same. It's just that now we have to find for something slightly different. Find 3 numbers that sum up to 2020. So one way, if we get back to the naive approach, is to okay. So if we get back to this and we want to find 3 numbers, this is kinda not gonna work because you will always have to, you will have to do like 3 loops. I see it, I would say pretty complicated. So I will build on our second solution, and I will leverage the fact that we know that our input is sorted. So so we can actually tell that if we start with what we have the first and the last number, and we sum them, then most probably we need to find another number, and that number will be on the lower side of your array, of our array, because given that it's ordered, the most probable part is that you have 3 smaller number. Okay, so we still need to keep the 2 we still need to start from the 2 extreme ones, but we will put another one in the middle. So we sort our list. Oh, I'm totally not gonna count up the cost for now, maybe later. So we sort our list, pick first and last item, and then I would say we pick the second. Even though I wonder if taking the second actually make sense to take the second or to take the one in the middle? I would say let's go with the one in the middle. Okay, so that means we're taking the first, the last, and the item in the middle. And now we have, so those numbers are an F, an L, and M. And so what are the possible solutions? Well, the first, so if an F plus an M plus an L it's equal to sum, you're done. I mean, let's write everything just an L. And this will display badly. Okay. Otherwise, now we have a bunch of situations to check. I would say the first one being if an F plus an M is bigger than an L, that means yeah, okay. Ah, no. So how can we do this? Let's see, if we do this, it means that we have the smallest possible number, we have the middle one, and the sum of these two is bigger than an, no, okay, wait, first of all, we still need to check if totally we are bigger or smaller than sum, for sure. So let's imagine we are bigger than sum. Now we need to check where we are getting, let's say we are getting over. So if we check an F plus an M major than an L, now let's I'm trying to find the way where we move from the right. Okay, so now I'm saying if our last number is bigger than the sum of the smallest and the middle one, yeah, in this case I will reduce the last one. If that's not the case, let's go with all the ifs. So now we're saying if an F, but this is actually not the alternative. Okay, this is not the right way of doing this, pretty sure. Because now I would like to say if an F is smaller than an M plus an L, so the middle plus the loss. No, wait. This is something I will check if you're doing something smaller. Yeah. So let's keep hammering on this part. Our sum is bigger, so we need to find a smaller way. No, I don't think this is pointing us to the right place. Maybe something like if sum minus an f plus an m. So this represents how big an L should be. So this is saying if this is bigger than an M, so I'm taking my array. I'm taking the element in the middle. Now I'm saying if the small one and the one in the middle sum together and removed from the total sum. So what the remaining part, if the remaining part is bigger than my last item, no, sorry, the remaining part is bigger than the middle, that means I need to move the middle back. I'm not sure I will get somewhere this way. So in this case I will do an m minus 1, but then I can't be sure that this is the only right way of doing this, because I think, yeah, I think this is not the only solution, because if your small part, let's say small part of the sum is actually no, this should actually give us maybe a hint on an L. Okay, let's try something more brute force. We're doing this, so we're checking the three numbers. We put an M. No, we don't do that. We just we iterate all the numbers from an F to an L, call it an M middle, and then we do this. Is it a good approach? Not really. I'm not sure. So if this is not correct, so if we didn't find the sum and the iteration is gone, then we go back to the old thing. So after iteration, if the same stuff, an F plus an L sum, take an L minus 1, etc. like before. Oops, wrong terminal. Okay, so Well, I tried to find a clever solution. I failed. I mean, I have no good ideas. We have to put our dummy input back. So we're putting our old input lists right now so we can check the answers. And so what we said that we want, so we do this while, and then we do for. Okay, now I need the proper for notation. Python C like for loop. Is there a C like for loop? No, right? There wasn't one. What the fuck, people? Really? I need to use a while? Oh, come on. I hate whiles. So nm, well, we start from the smallest one, and now we while. We while nm minor nl. Input list nf. None equals sum. If it's equal sum, we are good to go. Otherwise, and this is where the magic begins. So if you're not returning, we do an m, we increment an m plus 1. Yeah, and then we don't really care about an m after we finish the while, because yeah, I guess we can still keep the same logic. I don't know. Quality. Yes. Well, first of all, we can't really I mean, we are not bounding this thing properly, but it should not matter, I guess. Oh, shit. Okay, so this thing is not necessarily inside our loop, or is it? So in the example data, we need 99,266. So we need these three. And if we get the two last, what's the sum here? Let's find a calculator. 1, 4, 5, 6 plus 1, 7, 2, 1. Okay, this is 3,000. Okay, 3,100 whatever, summing these two. So in our case, well, this is just bigger. So we don't, okay, well, we are wasting time because we're doing something that's completely useless. So maybe we can do this check. Right. So let's check first if our our bounds are more or less than the sum. And if not, this is good. So if they're not bigger than the sum, we don't care if they're equal. So we just care if they're not bigger. If they're bigger, we will reduce from the right. Still makes sense. If not, we will try to put an element in the middle. So in this case, we will keep the first element. Well, no, okay. So first iteration, we will stop. We will hit here. It's bigger than 2020. So let's reduce and let's pick these two. And now these two, we start the iteration. So the iteration, we start with this one. This is just waste of time. We should start with the +1 because, well, I'm assuming we're not taking duplicates. And so we start from this one. We sum these three. I mean, we do all the sums. It's not going to work. And if it's not going to work, we are increasing the small side. Yeah, okay. Now we are checking if these two are more than the sum. In this case, I guess they might not be. Not gonna do the math. And then we put something in the middle. Okay, well, maybe that's enough actually. Or maybe it's not. So very well. We are going to put a lot of prints now. So what do we want here? We want an F, an L. Oh no. We want input list an F. We want input list an L. and we want their sum. Okay, that's the first thing. And then if when we are here, let's put this one. So we want an F, we want the middle one. And we want the sum okay. Stupid beam. Please. Long lines. Everybody loves long lines. Totally don't want to do this now. Don't do long lines. They're bad. And many spaces. Okay. Not really what I expected. So this is outer loop. This is the inner loop. Oh, we have a lot of spaces here. Okay. Okay, well, first of all, why our outer loop starts... Oh yeah, we sorted our stuff. Stupid me. Okay, so print okay, so this is our input. We are taking the first and the last one. Our sum is 2020. We don't care. And so because we don't care, now we're moving here. And we're moving here. Okay, makes sense. We are summing all our numbers in the middle, and we are getting, well, trash, bigger things. Now, we're going out again with 366. Oh, because then we're doing this. But 299 is part of our solution, right? Not in this case. Okay. 287, and for some reasons I don't understand, we are not doing the computation. Why you don't like this computation? I don't know. Okay. Well, the first thing I don't like on my code is, well, this part doesn't make sense. I mean, no, oops. I would I think maybe it makes more sense not to write P, to paste stuff. So let's do this loop just every time. Maybe we will find optimization later. Okay, so at least we're doing more loops. We are taking 299, we are taking 7021, and then we are trying 46, all the one in the middle. Okay, we find nothing. So, okay, the next time, because this sum was bigger. Oh, but this was equal actually. How do we manage? Okay, maybe the problem is that we're managing bigger than, but also equal. No, huh, okay. I still prefer this one anyway. So now we're taking, yeah, we're getting this one. We are trying the one in the middle. Still nothing. Okay. So we are going, oh, here you go. Here we are not, yeah, so we are increasing every time. Because from 299, then we're moving to 366 here, and then to 600, and then 366, okay. And then we're doing 6, keeping the same, okay. And then we are decreasing, and then we have no numbers left. So the problem in this case is that I still want to keep this 299. Is it actually part of my solution? Even if it's not part of my solution, it doesn't matter, but I need to keep this one anyway and check all the other combination because I mean, obviously I will need to decrease because I have to put another item in the middle. So maybe one thing I can do here is to have max sum. I place it at the rightmost item. So in our case, an L. I'm doing this. No, I actually really want to compute it just the sum. So my idea here is if I compute the sum inside every time, and I have a sum that's bigger in an inside sum that's still bigger, it means that I still have to decrease from the right. And so that's actually my criteria and not this one. So I put a basic sum. That is this one. We put list NL. And now inside here, yeah, actually. I'm saving this as max sum, and then if max sum is equal to sum, doing my stuff. Otherwise, I move on, keeping the same logic. And now here I use max sum again. And so if not the external one, but every time the internal sum is bigger than, then I decrease from the right, otherwise I increase from the left. And maybe, yes. Oh, thank God. It was started to be embarrassing. So that seems to be fine. It takes an incredible amount of time, but let's blame the print. Yeah, okay. And now we put our input file in here. Sorry for this. So yeah, we need to remove all the prints. Clear. Oh really? Come on. Shit. Oh. Okay, the fact that I closed the file, I mean that means that I do not have my debug prints anymore, and that our thing just doesn't work because it's not computing anything. Hmm. Hmm. Yeah, okay. Well, I don't know any better solution than adding back my prints for yours and my incredible enjoyment. So out. This is the outer loop. Please help me, Vim, help me. Come on. Okay. I want to have the max sum, and then I want to have this and that. Okay. Copy this, paste that. It was too good to be true. After the max sum, and then we add an input list and Very well. Opla. Whoa, okay, this output is long. Okay, so, well, we don't know what's the order, but doesn't really matter. Yeah, one thing we need to know is that this is outer loop and this is inner loop. Otherwise, it's complicated. Okay, so that's our outer loop. And then all the stuff in the inner loop. Oh, okay. Yeah. Simple issue. This is not max sum. This is current sum. And then we are checking current sum anyway. And before the iteration, if car sum is bigger than max sum, max sum is equal to car sum. We didn't update our sum. Totally not the problem. Yay! But I guess the problem is there somewhere. Maybe. So for example, in this outer loop, we're checking 155 and 882. So we reduced from the right a lot. Oh, and then, okay, that's the other problem. Then we are keeping the one on the right, assuming that it will be always somewhere in the middle. But I guess that's the wrong assumption. Yeah. So with this code, I'm saying if I scroll from a small to big thing, and in the middle I found at least one sum that's bigger, then I have to reduce from the right. And I guess, but this is gonna just completely fuck up the computation. If I'm finding that the global max sum from the right, it's still too small. Yeah, so when I'm getting here, I fear that I will have to reset the big one. Do I? Maybe I do. So every time I will find a sum internally that's smaller and I didn't find my final sum, I will move from the left. So I will take a smaller number, and that means I have to restart. Maybe. My gut feeling is telling me that this is okay. Well, I'm getting a solution, and now it's getting late. Okay, well, the time for this thing is incredible and huge. So totally not a good solution. Is it? Oh. Okay, but it's right. So I will note these as three numbers horrible solution, and then vim 02. This is the one. This is better. This is a two number better. Thank you, Vim. Two number better solution, and 01. This is the two number naive solution. So I will post this on GitHub. So as you might know, on github.com/Rigatto Twitch, you find the recaps of my streaming, the upcoming ones, and all the logs that I'm writing for live, and you will also find the link of the streaming. So and that's on YouTube. Amazing, right? Yeah, amazing. So you will find all these things about this one here, I would say tonight, hopefully. You have the calendar of all my future streaming on Google Calendar, and they are also on Twitch. I guess that the next time is the day after tomorrow, so we will skip tomorrow Advent of Code thing. So day 2, it's on your own. I will do day 3 together. But because I'm pretty much very curious to find a better solution of this, now I will spend like 10 minutes to cheat. 2020 day 1 part 2 solution. And as you could have seen by my search, I haven't cheated. So yeah, the struggle was real for the first part. For the second part. For the first part, I mean, I was actually able to do that. Lol. Rust, bash. Okay, so this guy is doing 3 loops. That's, I mean, makes sense, but I guess this is, yeah, this is just a huge loop. Okay, so this guy is putting some checks in the loops. Okay, I guess that sounds pretty similar to mine. Still 3 loop. Well, I'm happy that the internet is not like, ooh, JavaScript, giving things that are that incredibly better. I don't know what's auto, but a lot of people are using Rust. Problem 2. Oh, that sounds smart. Shit, that's a good way. Ah, come on. Okay. So I like this guy. So this is actually very smart. In fact, is reducing the second problem to uh, just uh, a special situation of our first problem. Well, first of all, the way it's counting is very nice, and because it's keeping track. So yeah, actually, this is even faster than us because it's doing it in ON, because it's taking track, it's keeping track of um, what is so. So it's iterating in the input, is saving the complement being is current item minus the sum it needs to get. And then if you already saw the complement, it will just return it, because that means you're finished. Otherwise, it will add it to the set of number that you saw. And then the second problem is solved just adapting the target with using the difference. So in fact, it's just solving. It's just solving the fact that he needs to find a sum of two numbers that is equal to our result 2020 minus the item is looking for. And so in that range, he needs to find the two numbers that sum up to that. And if you found that, you actually found your final solution. If not, you continue. Yeah, that's actually a very good way of doing this, and is way better than ours, because our solution was our kind of better solution was taking n log n time, because we were sorting first, and it doesn't need to sort to have this solution in big O n. And then our solution to the second thing, it's just horrible. It's just plainly terrible. And this is a way better. So I will totally save the link of this. Way better solutions found on Reddit. You don't need this. Here we go. Okay, so I put everything online, and I can even do better. I can actually put the link here. Yep, and then Twitch. Here you go. You will find the notes, code, and recording on GitHub. So yeah, but maybe I can even actually show the page. Yeah, why not? So thank you very much for being here. and see you in 2 days.